In the next few minutes, we're going to explain the exercise that we've gone through. Here we have three panels. One is the Blue Jay Class A, Class B examples, which we used in our classroom exercise for inheritance. The right-hand side is actually the answer sheet from the quiz that we did interactively, and you can see that uh, our result is like average, and the number of answer correctly average is 11 out of 18. Uh, the green one is the correct answer. The red one is the wrong answer. And these are the names, but I don't really want to intentionally recognize you as such, but it's served as a reminder of how you did in the classroom. So now what I would like to demonstrate now is to show that actually once you install the class car, you can see that our class A is as such, and then our class B is as such. And from here, you will know that method one there in the is available in the superclass as well as subclass. Method two is only available in the superclass. Method method to string is available in both, and there is a method two with one argument is distinct from class A method 2 in class B, and that is of course overloading. Um, I would like to explain the using the things that we have gone through graphically also. Uh, Sorry, this is the wrong size. Here is the correct one I want to show. So we know that class A has this, class B has this on the right hand side, and these are the source code. The first thing we notice that of course the instance variable name is inherited and it's private. You need to use assessor to set the name of class A. Secondly, we notice that method 1 occurs in both and is inherited, and is actually what happens is that in the superclass it prints 1, but in the subclass it prints sub 1. So it's overriding by replacement because the whole thing is replaced, right? The second thing to notice is toString. toString. toString is overriding by refinement because there's a remnant of the method of the superclass method called toString. So this one just added the prefix called subclass, but then it will still print the name using the superclass method toString to print. So it's called overriding by refinement. We notice that method 2 will be inherited here, and here you can actually in class B object can use method 2, but it'll be using the superclass method 2. On the other hand, subclass class B has a method 2 method itself to itself, and but it is an overloading one to method 2 because it has one arguments instead of 0 arguments. So that pretty much is what we understand the situation to be. Now we will go to answer the first question. Name a method with overloading, right? So obviously that would be method 2 of the class B, because we know that in the previous diagram we already showed that this is the overloading one, method 2 of class B. So that's the answer. Next, we will show that we will ask that name a method overriding by replacement. And of course, if you look at the answer again, overriding by replacement is method 1 because 1 is replaced by sub 1. So the answer will be method 1 of class B is a replacement. Then the next question goes to name the method that is overriding by refinement. Again, we look at the diagram that we was just shown. We will know that this is overriding by refinement. The method is toString because the subclass toString is added with a prefix subclass there. So the answer is uh, toString method of class B. Next question is asked that whether this statement can go through or not. The way to verify that is class A. We can do this on the code panel. New class A, name A. It go through. So the answer is true. The next one is to create another variable of class B. Is class B, new class B, and the name is B. It also go through. So the answer is true, both case. Question C, B dot method 1. So we'll be calling the subclass variable B, and then it'll be calling method 1 here. Okay, method 1 here. So now you return it's sub 1 because method 1, remember, of class B, method 1 of class B is a overriding by replacement function. So when method 1 is called, it will do this sub 1. And that's the answer, sub 1. Okay? Then 2D, question 2D, B dot method 2, B dot method 2 without arguments. We know that this can be done because it's inherit from the superclass, and the answer will be 2 because again, you coming from here, you know that this will be method 2. We're just calling this one because there's no method 2 in class B. It will just call the superclass method 2, which is inherited here, right? And then goes to 2E is B dot method 2B. Can this go through? Does the subclass B has a overloading method, method 2 with argument? The answer is of course yes, and then it will be print out sub 2B, sub 2B, also sub 2B is correct. And of course, if you look at the slides again, you are calling this particular function because this is an overloading function, and the output will be sub 2 plus the name, and the name in our case is printed and it's B. So the answer is capital B though. You know, some people put the lower, no, I mean, or combine together, but you actually know that there's a space there. So this is the correct answer. Okay, B. Yeah. Okay. Uh, then go to 2F. How about printing the object itself? Print line the B object itself. Will it, okay? In this case, it will be printing from the subclass, subclass B here, right? Oh, this one doesn't check case, so this one is correct. Okay, but strictly it should be capitalized B because uh, just now we already named the uh, subclass to be class B, and here you got it from looking at the overriding refinement of the toString here, and it will be coming from here, subclass, super, and it will be calling this because the the name is already capitalized B, so it will show up as subclass space B, capitalized, and is this answer here. Okay, then the next one to F to G is uh, where we exercise the principle of substitution, substitutability, where you can have a superclass variable uh, assigning, being assigned a subclass object. This is class B is a subclass object with the name C and is assigned to a variable C of the class A. Can this be done? According to the substitutability principle, this one can be done because class B is a subclass of class A. So the answer should be true here to G. 2H. 2H says that now you want to invoke the method 1 of the variable C here. Can this be done? And if it can be done, what is the answer? Okay, we run it, and the answer is sub 1, sub 1. And the reason, of course, is that when this variable is run, first they check whether method 1 is part of class A or not. Okay, and then once it is class A, you will then allow the object to actually call the method. Okay, so what happened here is that uh, the method T, you check actually according to class A what are the method available, and method 1 is available. And once it's available, when it during the execution of it, you will actually call the most specific one, which is the objects attached to. The object attached is a subclass object, so it will be calling this method 1 rather than this method 1. So the answer is sub 1. Sub 1. Okay? Here again, I think this question is pretty typical. A lot of people got it wrong here. So please do exercise and think about uh, where the situation of C being a subclass uh, object assigning to a superclass variable C. So the execution of the method of that particular variable involves two steps. First, to check whether the method is actually part of the superclass method, and it is. It is okay because let's bring this the class car up for our checking purpose. Okay, so C is a class A variable, and method 1 is indeed method 1 here, a class A method. So firstly, it is go through, but when it during the actual evaluation of it, it will actually call the most specific method 1 because the object itself is actually a class B object. So the method it calls will be from here. And here, as we know, the answer will be sub 1 rather than, I think the superclass method has the if it is superclass, it will print 1 rather than sub 1. Okay, so it will print the subclass method 1, so it's sub 1. Now we move on to I to I. Uh, then in this case, C dot method 2. Okay, this one will be 2, as you can see, 2. Okay, because again, if you look at uh, the class car of the two, you will see that uh, method 2 is available, and it's going to just call directly the method 2 there, okay, 2. Yeah, because the subclass has no method 2. It's inherited from class A. So that's the answer to 2I. And 2J, where you will call method 2. C will try to call method 2, which is overloading 2, method 2. And in this case, would it run 2 or not? The answer is not, because as we mentioned, the C is actually a class A variable, and you look at it, there's no such method that is method 2 with an argument. There's no such method. So it won't go through. So you can see if it's run, it's it doesn't cannot find a method. So there's an error message. So the answer is false. Then of course, how about we are doing something like class B, a subclass variable D, whether you can take a superclass object or not. And the answer is false. Everybody get it right. This is a violation of the substitutability principle. Only the superclass variable can take subclass object. The other way around cannot work. Okay, and of course, since D is not even instantiated, of course, this one will be an error. So it's false, quite easy. And some people didn't answer, but actually it's just false. Uh, then the next question, 2M, is object class, uh, whether the variable object class, the top class, can take a class B object or not. Of course, the answer is yes, substitutability principle. This because the object is a superclass, so no problem. Yes, okay, no error. Uh, ML. Okay, now the next one is no is that then you want to cast the object variable obj into, this is casting into a class A variable. Can be done because obj is a superclass. Okay, can be done, no problem. True. Okay, it should be true. Yeah. Last one question. Then when you call this E method 1, what would that be? Uh, Recall now, E is now a class A variable. Okay, so class A variable, of course, definitely has method 1. Yeah, but then, so that is the first step. And but when actually during the execution, then you will revert back to uh, the variable actually is bind with class B object. So again, the method 1 will go to class B method. And as we see that here, class D method 1 is the one that will be called, and this one is overriding by replacement method of method 1. It will be calling this method, and the answer will be sub 1. Very good. Some of them, most of you, actually, majority of you get it right. You know, this is pretty tough, but you get it right. So I think you all have done this last question well, and that's the end of the current explanation.